The fact that if you get deep under the surface, it's wet and hard is a weird sciencey fact that boggles my mind. Scientists believe that they have discovered a mega ocean's worth of water deep below the Earth's surface. In fact, it's believed that there was so much water about 400 miles beneath our feet that it could refill all of the Earth's oceans, rivers, and lakes 3 times over. But it isn't water the way you think of water. You know, water. Whoa. And it's not ice or steam either, it's basically rock. It's a substance called ringwoodite, which is a pretty blue mineral that's porous, and under the high pressure deep below the Earth's mantle, it actually causes water to separate into OH and then bonds with it. When this happens, up to 1% of ringwoodite's weight can be water, which might not sound like a lot till you think about just how much rock is down there. It's a lot. And now you might be thinking, that's a cool factoid for Friday Night Trivia, but what does it mean? And that's a great question, and it may hold the keys to the secret of what makes our blue planet green. Now, there's lots of planets in the universe, but ours is unique in a very special kind of way. That's that we are the only planet we know of with liquid water on the surface. Water is the reason that we are here. Water is the only reason we survive. And why is it that we're the only ones we've found so far that have it? Now, there's some answers to this. Some planets are too far from a star and all of their water is frozen. Other planets are too close and it's all burned off. But even the planets we've seen in the Goldilocks zone, you know, not too hot, not too cold, still seem to be missing that moist. So scientists have long theorized that we got our water from icy comets crashing into Earth in its early stages. Us being the only ones with water kind of throws a little bit of a wrench into that theory. For example, why does the moon have water on the surface? Or why doesn't Mars? They should have theoretically been hit with all of the same icy comets we were. And at one point they likely did have liquid surface water, but it seems like it's gone now. This ringwoodite may be the missing link in that mystery. For a long time, we've pretty well understood the cycles of surface water. It evaporates, it rains, it soaks into the ground and fills up reservoirs and then comes back to the surface through root systems and springs. But other planets like Mars should have had similar cycles to ours and they didn't keep their water. And why is that? Well, now we have reason to believe that tectonic activity like earthquake and volcanoes allows water to get way deeper down in the mantle than we ever thought possible. And when that happens, it could get trapped and get bonded in that ringwoodite transitional section of the mantle. And this could have been what allowed early Earth to keep its water locked away while other planets were losing it. And then as best as I can tell, what happens through that tectonic movement is some of that ringwoodite moves up closer to the surface. And as it loses that pressure, it can't keep its water and it literally starts to melt. It's called dehydration melting, and basically all of that water that was inside that mineral melts its way out. So the theory is starting to evolve that potentially when early Earth's surface didn't have the conditions to retain liquid water, it was all locked away deep below the surface, and then when the conditions did become more favorable, the rocks could have literally just sweat out the water. The oceans could literally just be Earth's sweat puddles. You know, probably why it's so salty. Think about that next time you go swimming. Point is that this could be an incredible discovery on unlocking the mystery of Earth's history. And I say could be because we honestly don't know if we've discovered anything. Turns out that observing what's going on 400 feet beneath our feet is a hell of a feat. And because Aaron Eckert and Delroy Lindo haven't actually built us a subterranean submarine thing yet. There's a niche reference I'll be surprised if anyone gets. Scientists need to get a little creative when it comes to studying the inner workings of the Earth. One of the ways they do this is measuring sound waves from seismic activity like earthquakes. And when those sound waves move through that transitional period where all of that water could be held, they come back slower. And because water is less dense than rock, this leads them to believe that it's doing that because there's water there. And another way they try to put together the puzzle is they recreate the conditions going on down there in a lab. They squeeze water and ringwoodite between diamond and gemstone anvils to recreate the pressures and conditions of what's going on deep below the Earth's surface. And by doing that, they've been able to demonstrate in a lab that ringwoodite does in fact take on water, and this is all plausible. And all of these theories and this work is built on a discovery from a year ago that was akin to winning every lottery on Earth multiple times over. A volcano in Brazil spit out a diamond, and encased in that diamond was a piece of ringwoodite. That diamond formed around that ringwoodite 400 miles down, sealing in that moisture like a food saver before ejecting it all the way up to the surface. Then I guess it was just a scientist's lucky day when they found it and decided to take it back to the lab with them and discover this, because it is the only example on Earth. And that is just crazy to think about all of the things that had to go right to make that discovery. So while it's still not a smoking gun, it's allowing scientists to form a pretty solid theory with all of the circumstantial evidence. This could lead us to some really cool realizations about the history of our planet. And the fact that water molecules melding with minerals in the mantle may unlock the mysteries of why we're moist, well, that is pretty mind-boggling.